Okay, welcome back. Now we're going to look at solving DCF problems using Excel. I want to look at Lukoil's project to renovate its gas station at 24th and 10th. And Lukoil believes that the renovation, if they've done it instantaneously, would cost $650,000 and provide it with $100,000 a year net cash flow after tax starting at t equal 1. And the opportunity cost of capital they have for renovation projects is about 8%. They've been doing this for 30, 40 years, so they feel like if they don't get that 8%, it's not worth doing, 8% or more. So let's find the NPV, see if Lukoil should go ahead, why or why not. I'm going to jump into the Excel now. I'm going to do this with NPV and also with IRR. But I just want to point out here that I do have the answers shown for us here for both NPV and following for the IRR. So you're welcome to come back and refer to these answers as necessary. Okay, with that, let's jump right into the Excel without any further ado here. And you can see the big difference that I've got set up for us now compared to our time value of money chapter is whenever we're working with a discounted cash flow method, that's going to include the NPV method and the IRR method. Now we're always going to be considering all the cash flows for the project for one person, one entity, one player, all lined up together, including anything that happens at t equal 0. So we're not just concerned with the future cash flows for the project. We include in our calculations for NPV and also, of course, IRR, every stinking cash flow for that player. In this case, the player is Lukoil itself. Okay, so for the NPV, what we need to do, we have all the cash flows laid out here and the times of the cash flows up in the row above. What we need to do, as always, with the NPV method is first we need to individually discount each of those cash flows, i.e., bring those cash flows back in time to their equivalent at t equals 0. We can't add them up until we do that. First, you got to get them all on an apples-to-apples basis. Then we're going to add them up. So with the NPV method, I want to discount all of these cash flows, starting with this first one that happens at t equals 0 by the opportunity cost of capital. That's the way the NPV method works. So that's what I'm doing here. And I want to take the 650,000 divided by 1 plus 8% to the 0. Anything raised to the 0 power is 1, so I should get minus 650 here. Also, notice how I have a proper sign convention for all the cash flows now. So everything works out rigorously, mathematically for Lukoil. This is a negative cash flow at t equals 0. All the other cash flows are positive. So with the NPV and the IRR method, we're going to be working with a rigorously correct sign convention. Okay, so I think I have a general formula here that's pretty good, so I'm going to try to just pull it along and hope that that will give me the present value, the equivalent value at t equals 0 for every one of these stinking cash flows, and it looks like it does. So it looks good because each one is smaller than 100. The denominator is always bigger than 1, so I'd expect that. And they're getting smaller as time goes on because the denominator is getting bigger and bigger, so I'd expect that. And then the other quick check I can do here is just change my discount rate or interest rate to 0. And if I do that, there's essentially no time value of money. Cash flows in the future are equivalent to cash flows at t equals 0. That's what I've got. So I've checked that. Looks pretty good to me. So I put my 8% back in. I'm pretty confident. Now I just add them all up. And what's going to be our rule? If we add up all the apples to apples cash flows for one player, Lukoil, in this case, if they're greater than 0, then we want to go ahead with the project. If they're less than or equal to 0, we don't. So let's see what we got here. So I'm just going to sum them up and put that sum in the NPV cell here. And I get 21. That's clearly greater than 0. 21 is greater than 0. And so we say, therefore, they should go for it. Okay, so that's it. Okay, all right, so now let's go ahead and use the IRR method in its formal discounted cash flow guides here. So what I have now are, once again, I have all the cash flows for Lukoil for this project, and I have the time of each cash flow. So I always need both of those. And then, as usual, I'm going to discount all of these back to 0. And if you look at this, you'll notice this is really exactly what we did with IRR part 1. We took the cash flow at t equals 0, moved it over to the right-hand side of the equation, and then we got an equation very much like this. 0 is equal to the sum of all the cash flows starting at t equals 0 discounted by IRR. So that's what we were informally doing before. Now we're formally doing it. We always, in our summation, include all the cash flows, including any at t equals 0, with a proper algebraic sign convention. And the catch here is that we don't know the IRR. The IRR is the interest rate or discount rate that's going to make this equation true, to make this sum, this normalized sum at t equals 0, equal to 0. Okay, so let's put a guess in there. That's the way we always do this in Excel. Anything that we don't know and we can't trivially, easily solve for with algebra, we take a guess at it, and we're going to use goal-seek to help us find it. Okay, all right, so I got the same deal here. I need to discount each of these cash flows, so now I'm going to discount by 1 plus my guess for the IRR, and I want to lock that down and raise that to the amount of time that's elapsed, which in this case is 0. And I think I've got a good general formula there. Yeah, it's looking pretty good. I do my double check again. Yeah, that's good. Okay. And now my sum of the present values is actually the NPV, because I've summed up all of them. So I'll put that in there just to make that clear. And now I sum them all up, just like I did up above. All right. And I get 248.3. So if I try 6%, I'm getting close to 0. And as usual, I could keep trying this until I get to 0, but I'm way too lazy to do that. So I'm going to use goal-seek. So I go to data, what if analysis, goal-seek, set cell C28. That's my sum. I want that to be the sum, the NPV to be equal to 0, and I do that by changing my guess at our interest rate, the IRR. And there we go. So we've got 8.7%. Okay. And that is greater than our ROCC. Okay, so in this case also, we'd want to go for it. And this brings up another point, which is important to think about. In general, in cases where you can compute the IRR, okay, and we know sometimes you can, sometimes you can't. In general, for sponsors, we're not going to use IRR, we're going to use NPV. But I used it here because clearly it works in this case, even though Lukoil is the sponsor. But the key point here is that whenever you can use both methods, they both have to point in the same direction. So if NPV says go for it, IRR needs to say go for it. Otherwise, you have a mistake somewhere. To put it another way, if the NPV is greater than 0, the IRR needs to be greater than the cost of capital. Otherwise, you've made a mistake. They always point in the same direction. Okay, so that's it for this chapter. There is more information here by way of an appendix on methods for computing opportunity cost of capital, but all of that is covered in great detail in Chapter 5. So I think it's a much smarter move to refer to the Chapter 5 lecture materials and videos. Okay, and with that in mind, thanks very much for watching, and I'll see you again soon.